Welcome to the chapter on Introduction to Machine Learning. Let us see what and all we will learn. We will try to define what is machine learning and understand what is machine learning. We will look at some of the application areas of machine learning. We will also look at the machine learning process and see some of the machine learning algorithms. We will cover all these algorithms in detail later. And we will also look at a summary of machine learning techniques and an overview of Scikit learn. So what is machine learning? Machine learning is a method of data analysis that automates analytical model building. Using algorithms that iteratively learn from data, machine learning allows computers to find hidden insights without being explicitly programmed where to look. So it tries to find hidden insights within the data. So where and all machine learning is used? It is used for fraud detection in the banking sector, real-time ads on web pages, web search results, credit scoring and next best offers, new pricing models, recommendation engines, customer segmentation, text sentiment analysis, predicting customer churn, pattern and image recognition, email spam filtering, financial modeling, etc. etc. We will explore a lot of use cases with respect to machine learning in this video. What can we achieve using machine learning? Identifying which category an object belongs to, also called classification. The example of classification could be spam detection. Predicting an attribute associated with an object. An example could be stock prices prediction. This comes under the category of regression. We will explore all these things in detail. Automatic grouping of similar objects into sets, also called clustering. This application could be customer segmentation and comparing, validating and choosing parameters and models, also called model selection. The area of application could be improving model accuracy via parameter tuning. What is the purpose of machine learning? Machine learning is a great tool to analyze data and find hidden data patterns, as we discussed earlier, and relationships, and extract information to enable information-driven decisions and provide insights into the data. So you have the data, you have machine learning algorithms here, which tries to identify patterns. It provides insights into unknown data, and it allows you to make information-driven decisions. So there are some machine learning terminologies that we will encounter across the course of this lesson. There will be something called features, response, observations, inputs, attributes, records, examples, samples, target, outcome, label, etc. So normally a machine learning approach starts with either a problem that you need to solve or a given data set that you need to analyze. So it could be just a raw data set wherein you need to come up with what kind of problem it is, or you already have a defined problem and you need to solve, and you are given some data set from where you need to find relevant information and try to solve the problem. So these are some of the steps. Understand the problem data set, extract the features from the data set, identify the problem type, choose the right model, train and test the model. We will look at the process of machine learning in detail and strive for accuracy. So these are all going to be iterative to some extent. Let's understand the machine learning process. So first of all, you need to acquire data. Now your data is going to have a lot of features. Then you need to clean your data into a nice format. Probably you can use pandas for that purpose, for cleansing of data. And then you have to split your data into test data and training data. You will train your machine learning model on the training data, and you will test your model on the test data which the model has not seen it before. And then you can iterate this process until you get a best fit, again between the training data and the test data. Then once it's ready, you can deploy your model. Let's not forget the thumb rule here. You get the sample data, you design a model that works for that sample, and make predictions for the whole population. Remember, these things have been discussed earlier in our chapters where we went through statistics and all other basics. You always need to work on the sample data and then you apply it to the whole population. Let's look at some more details of machine learning. There are three main types of machine learning algorithms: supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, you have labeled data and you're trying to predict a label based off of known features. In unsupervised learning, you have unlabeled data and are trying to group together similar data points based off of features. And in reinforcement learning, algorithm learns to perform an action from experience. Let us look at supervised learning in a bit more detail. Supervised learning algorithms are trained using labeled examples, such as an input where the desired output is known. For example, a piece of equipment could have data points labeled either F for failed or R for runs. Let us look at a visual example here. On the left-hand side, you have a training data set and it contains some faces of cats. Now, the cat's word itself is a label given to these kind of faces. Then, on the right side, you have a data set which has cats as well as other animals. Now, assuming that the left hand side is a training data set, on the right hand side there is a test data set. The training data set contains only cats, the test data set contains the faces of all other animals. Now, assuming that you have trained your model on the training data set here, and we have labeled information, which is we associate these kind of faces to cats and it is labeled. Now, in supervised learning, when you apply this to a test data set, which is on the right side, and try to predict. It says there are two cats faces and two which are not cats, right? This is because the model is trained to identify the faces of cats, which is labeled. So in the supervised learning, the learning algorithm receives a set of inputs along with the corresponding correct outputs, and the algorithm learns by comparing its actual output with correct inputs to find errors. It then modifies the model accordingly. So through methods like classification, regression, prediction, and gradient boosting, supervised learning uses patterns to predict the values of the label on additional unlabeled data. Supervised learning is commonly used in applications where historical data predicts likely future events. So you need some data as a base which has inputs and outputs in the form of historical data. For example, it can anticipate when credit card transactions are likely to be fraudulent or which insurance customer is likely to file a claim. So these are based on certain patterns or behaviors which are recorded in the past, and based on that it is able to predict, or it can attempt to predict the price of a house based on different features for houses for which we have historical price data. We will look at this use case at a later point of time. Unsupervised learning is used against data that has no historical labels. The system is not told the right answer. The algorithm must figure out what is being shown. The goal is to explore the data and find some structure within. Now here on the left hand side of the screen, you have the raw data. Now we know that these are circles or spheres with specific colors. Now this is not labeled as a red circle or a blue circle or a green circle. So this is just raw data with some figures which look alike, some are not. Now when the algorithm encounters this kind of data, it segregates and puts them in an output with items which look similar or identify themselves with some kind of a similarity. Now, just because these are blue and these are round shaped, it is grouping them into a blue set of spheres. So, and the same way, these are red and it is grouping them into a red sphere. So the goal here is to explore the data and find some structure within, or it can find the main attributes that separate customer segments from each other. Now, popular techniques include self-organizing maps, nearest neighbor mapping, k-means clustering, and singular value decomposition. These algorithms are also used to segment text topics, recommend items, and identify data outliers. With reinforcement learning, the algorithm discovers through trial and error which actions yield the greatest rewards, often used in robotics and gaming and navigation. So this type of learning has three primary components: the agent, the learner or decision maker, the environment, everything the agent interacts with, and actions, what the agent can do. So here it is. There is an agent, there's an environment, there's an action, and there is an observation and reward. The objective is for the agent to choose actions that maximize the expected reward over a given amount of time. The agent will reach the goal much faster by following a good policy. So the goal in reinforcement learning is to learn the best policy. So in a nutshell, you can say the supervised learning is a process of an algorithm learning from the training data set. The unsupervised learning is a process where a model is trained using an information which is not labeled, and reinforcement learning is learning by interacting with a space or an environment. So let us look at the comparisons between supervised learning and unsupervised learning. In supervised learning, the data set used to train a model should have observations, features, and responses. The model is trained to predict the right response for a given set of data points. In unsupervised learning, the response or the outcome of the data is not known. In supervised learning, models are used to predict an outcome. Unsupervised learning models are used to identify and visualize patterns in data by grouping similar types of data. This should be unsupervised. Please correct me. The goal of the supervised learning model is to generalize a data set so that the general rule can be applied to new data as well. The goal of unsupervised learning model is to represent data in a way that meaningful information can be extracted. So let us look at these steps one by one. So the steps 1 and 2 say understand the data set and extract its features. So looking at the below table, this table depicts the hourly billing rate for a IT professional. Okay. If a person has 16 years of education and has 1 year of professional training, he is billed at the rate of $90 per hour. Same way, if someone has 18 years of education and 1 year professional training, he is billed at the rate of $130. So the 16 and 1, 16 and 0, 110, 15 and 1, 105. There might be some of these numbers which might be here and there. For example, the 16, 190 is there, and 16, 0, 110 is also there. So this is how a data set is going to be. So the first thing what we need to do is we need to identify the features or attributes. So here education and professional training become the attributes, and these are some observations which we have in the data set, and we will use these two columns as predictors. And hourly rate, we identify it as a response, or we also call it as a label. So the next step is to identify the problem type. So data can either be continuous or categorical. Based on whether it is supervised or unsupervised learning, the problem type will differ. So here we see if it is supervised learning, in this case, which it is supervised learning. Now the data could be continuous or categorical. So if it is continuous, we need to apply regression methods. If it is categorical, we will apply classification methods. Same way, if the data, the problem type is unsupervised learning, then again the data could be continuous and categorical, and the problem type could be dimensionality reduction, clustering, etc. etc. So the next step is to train, test, and optimize the model. To train supervised learning models, data analysts usually divide a known dataset into training and testing sets. So normally 60 to 80% of the data is taken as a training set and the rest is taken as a testing set. The training set is something which is known. Then once an, a model is applied to the training set, it is actually put to test on the test data, which is an unknown set. So what happens is once you divide this into a training and testing set, a machine learning algorithm, say for regression algorithm, is put on the training set, and uh, it it could be an iterative process wherein you keep on uh, optimizing the model until you get the best results, and again then you apply that on the training set. So here if you see, these close to pink marked ones are taken as a training set, and these orangish yellow one are test set. So we separate the same data into training set and test set, and we will apply the model to the training set, and then we will get the response. So once the model is trained, then it is applied to the test set, and you have a response both from the training set as well as test set. So this is how it works. For the supervised learning model, a known dataset with observations, features, and response is used to create and train a machine learning algorithm. A predictive model built on top of this algorithm is then used to predict the response for a new dataset that has the same features. In unsupervised learning, a known dataset has a set of observations with features, but the response is not known. The predictive model uses these features to identify how to classify and represent the data points of new or unseen data. So here are some list of machine learning techniques, some of these which we will be learning. We have supervised and unsupervised learning. Under supervised learning, we have classification and regression. Under classification, we have support vector machines, discriminant analysis, naive Bayes, nearest neighbor. Under regression, we have linear regression, ensemble methods, decision trees, neural networks. And under unsupervised learning, we have something called a clustering algorithm, k-means, fuzzy c-means, hierarchical, Gaussian mixture, neural networks. We won't be covering all of them, but we would definitely covering some of them in each of the type. So here is the machine learning in a nutshell. You have supervised learning, you have unsupervised learning, and a supervised. We have regression and classification, and some of the areas where regression uh, can be applied is weather forecasting, advertising popularity prediction, market forecasting, estimating life expectancy, population growth prediction. Under classification, we have customer retention, image classification, fraud detection, diagnostics, And when we come to unsupervised learning, we have clustering, recommender systems, targeted marketing, customer segmentation, and under the dimensionality reduction methods, we have big data visualization, meaningful compression, structure discovery, feature elicitation, and we also have reinforcement learning, wherein we have application in game, artificial intelligence, real-time decisions, robo navigation, etc., etc. So here is where ML fits into the AI structure. AI as a whole includes machine learning as a subset, which has supervised, unsupervised reinforcement, deep learning, and then we also have reasoning, NLP, natural language processing, planning, etc. We will deal in all these in detail later. Now let us see how we can use Scikit learn package in Python. It's the most popular machine learning package for Python and has a lot of algorithms built in. You will need to install it using conda install scikit-learn if you have Anaconda installation, or pip install if you have any other installation. For example, you have Anaconda install. I say conda install scikit-learn. So this will take some time and install the Scikit package. Sorry, it should be scikit-learn. And it should install the Scikit package. Once it is installed, you can just say conda list, and you should see that the scikit-learn should have got installed. It should be listed here if it is installed. So make sure you have the internet connection available while installing the package. When scikit-learn, every algorithm is exposed in via an estimator object. So for this, you will need to import the model. The general form to import the model is from sklearn.family import model. For example, if you want to use the linear regression model, you need to say from sklearn.linear_model, which is the family, import linear regression, which is the model. There are some estimator parameters. All the parameters of an estimator can be set when it is instantiated and have suitable default values. For example, you instantiate a model by saying model is equal to linear regression, and you pass this parameter normalize is equal to true. And when you say print model, it is going to show some default parameters which have been set. Copy underscore x is equal to true, fit underscore intercept is equal to true. Don't worry about memorizing all these things at this point of time. So once you have your model created with your parameters, it is time to fit your model on some data. But remember, we should split this data into a training set and a test set. Let us see how we can create some fake data. So normally we will be using CSV files and other data sources for our data. Here, I'm just showing you by creating data using NumPy and trying to get a training set and a test set. So here I import NumPy as NP from sklearn.cross_validation. I import this method called train_test_split, and I create two arrays x and y with an arange function of NumPy, and I reshape one of them to a two-dimensional array and the other I leave it as a single dimensional array. So x gets this two-dimensional array and y gets this one-dimensional array, a range of 10, which is split into two arrays. Then here I create 4 variables x underscore train, x underscore test, y underscore train, y underscore test. So train is going to be the training set, data set, and and the test is going to be the test data set. And I call the function train test split with the xy arrays which we set it in our previous slide, this one. And then I pass a test size of 0.3. So remember here that x are the features and y are the labels for those features. So when you use a train test split, it automatically gives you a training set and a test set. Let us not get into details of how it is giving it. We're just using this function for our example. And don't again worry about memorizing this too much at this point of time. So here you have both the features and the labels for your training data and the labels and features for your testing data. This is, if you output it with x underscore train, this is what it shows you. Now that we have split the data, we can train or fit our model on the training data. This is done through the model.fit method. You say model.fit and pass the x underscore train and y underscore train, the label and the feature of the training data set. So remember that this model was the object which you instantiated, and x train will be your features and y train will be your labels which you're trying to pass and fit into the model. Now the model has been fit and trained on the training data. The model is ready to predict labels or values on the test set, which is the test data. So in supervised learning, we get predicted values using the predict method. So we say predictions is equal to, predictions is a new variable. We say model.predict and we pass the x underscore test set, which is the test data features. Now we don't know the outcome of this because we are trying to predict it. Remember that this is supervised learning process. For unsupervised learning, the process is going to be slightly different because you're not going to have those labels. We can then evaluate our model by comparing our predictions to the correct values. The evaluation method depends on what sort of machine learning algorithm you're using. Example, regression, classification, clustering, etc. Different evaluation methods are used for regression, classification, clustering, etc. Scikit-learn strives to have a uniform interface across all methods, and we will see examples of these. Given a scikit-learn estimator object named model, the following methods are available. Let us see some of these methods. Model.predict underscore proba. So this is available in supervised estimators. For classification problems, some estimators also provide this method, which returns the probability that a new observation has each categorical label. In this case, the label with the highest probability is returned by model.predict. Again, this is also available in supervised estimators, model.score. For classification or regression problems, most estimators implement a score method. Scores are between 0 and 1, with a larger score indicating a better fit. In unsupervised estimators, we have model.predict, predict labels in clustering algorithms. Another one, in unsupervised estimators, model.transform, Given an unsupervised model, transform new data into the new basis. This also accepts one argument x underscore new and returns the new representation of the data based on the unsupervised model. You have model.fit underscore transform also under unsupervised estimators. Some estimators implement this method, which more efficiently performs a fit and a transform on the same input data. This is a small cheat sheet on deciding when to use what kind of an algorithm. This has been uh, taken from the scikit-learn site itself. You can also download it. It's a small cheat sheet. For example, when you start, if you say if there are more than 50 samples, and if it is a category type of data, yes or no, and if it is no, if it is a quantity type of data, then yes, and it goes into the regression, and then you decide on whether to apply this regression model. If it is yes category, and if it is a labeled data, probably and then you go to the classification kind of algorithms. So this you will increase your ability to decide on this based on your experience as we go deep into machine learning and deep learning. Thank you.